4, but that's...
Maybe we should do just the two around the table to see if everybody knows each other.
Yeah, we'll definitely do that. But is Sagi in yet?
I don't see him here. I don't know if he's planning on coming or not.
Let's ping him and see if he's can make it.
Are you pinging him, Greg?
Yeah, just that. Second.
I think you're really like up to date with all the new technologies. Let's ping him, and and he's on Slack and everything. If I ask my colleague professors that are already a long time at the university to just log in on Slack, they already say, "Oh no, another application." So that's really great.
Pretty savvy group.
Yeah.
Yeah, Sagi might not. Sagi doesn't list himself as being active at this very moment. I sent him a Slack message, but.
Oh, okay.
So maybe maybe we just start.
Sure. So the meeting notes I circulated. So if someone's game to just sort of like fill some stuff in as we have a conversation, that'd be great. But yeah, thanks, John. As Thibaut suggested, why don't we go around the room and say hello?
Kevin.
Hello.
Hello.
Okay, let me make just a few introductory comments here for everybody. So we're actually very privileged to have 3 people who are going to join us for 6 or 7 months. There's Saragari, who is live and well on the screen. So she'll tell you about herself, but she has just arrived a couple of days ago with her husband and 2 lovely young children, and they're just sort of starting to settle in. They've got a place in Vancouver, which is not easily come by, and so she's coming in remotely. Then there's Kevin Fan, who is just joined us yesterday. So Kevin was a university graduate here and has been doing some work in Myanmar. And he's now going to be coming back, and he's going to work with us for throughout the summer. And Bahid Aristani, who is now a new Iranian recruit, after Maysam, who was here for a year. Turns out Maysam and Bahid are at the same university, and Maysam was actually a student of Bahid's a number of years ago. But they don't communicate. So now they're going to be working together, but because of connections with UBC. And then today we just had a visit from a Brazilian colleague, George or Jorge. George is okay, and he's just visiting. So we have some new members, and I think with that, let's just go around. Each of them can tell a little bit about who they are and what they're planning to do here. So, we'll start with Kevin.
I'm still a bit out of breath, actually.
Okay.
Grab someone else first. Sorry.
Okay. Okay. Well, George, you can start. So
okay.
Probably.
Can you turn the mic? Sorry, I can't hear.
I teach geophysics in Brazil. I work with computational geophysics, but mainly with processing, analyzing data. Recently, I have been working especially with phenomenological issues. So, how can I say, solid Earth? So, we study geomagnetic data, mainly looking for pulsations, for recurrent paths in geomagnetic pole in the past from paleomagnetic data, and things like that. But I did a postdoc in Rio de Janeiro, in National Observatory in Brazil, working with some electromagnetic device low induction number and magnetotelluric also. And right now I was trying to meet some people that also has this interest in electromagnetics, geophysics, and maybe interact with. That's my main idea here.
Okay.
And one other thing, so George also teaches an introductory course of geophysics for geologists at his university.
Okay.
So it's really the only, I guess it's really the only geophysics course that's available to them. And so it's very, very similar to, you know,
your online notes
course that we have.
Okay.
And right now for a textbook, he's using Reynolds, which you remember that book. But he's just sort of talking a little bit through the, you know, the GPG, and so yeah, he might start using parts of that.
Excellent.
Anyway, so there's a number of connections, both with respect to introduction of geophysics for geologists, as well as just general computational geophysics, because George is very interested in, you know, signal processing in particular, but with applications to electromagnetics and in particular, you know, magnetotelluric stations under the electrojet. And so there's, yeah, quite a few potential connections. Plus, he started out as a Python programmer, switched to MATLAB, but now is on the fence. So.
Why the switch to MATLAB? That's actually abuse, no?
It's expensive. It's an expensive mistake.
So, Sarah, maybe you'd like to go next?
Yeah, that's fine. Okay. So yeah, I'm Sarah, and I'm from Belgium. I'm a professor at the University of Liège on the bioengineering campus in Gembloux. So that was actually for 150 years an independent agricultural university, and is now adhered to the University of Liège. There I'm teaching, not really, I have one course, introductory course on geophysics, but I'm more in everything that is related to soil and plant interactions. So things like fluid mechanics, irrigation, edapology is also one of my courses. And I have one course which is called Integrated Project on Hydrogeophysics. And actually that's just to be sure that it's an optional course, but in Master 2, that is available to the bioengineers now. So since I started, I actually forced it into the program because I thought it was really a pity that they did not come into contact with geophysics before having the opportunity to do a thesis, for example, with me. And so that's why it's now in the plan. And actually I do use, that's also one of the reasons I contacted you to come here. I do use your online course there also. So what I have my own slides, but then often I tell them, if you want to go more in depth, check these methods online in your textbook, or your, how should I call it, your information.
Which side? Which side?
Sorry?
Which side? The EM GeoSci?
Yeah, this, the one that is also in the notes there. The GeoSci.xyz.
Is it the GPG, like geophysics for practicing geoscientists?
Probably it's that one, yeah.
Cool.
I think, yeah. So I don't use it like, let's say, actually in the course, but I refer to it for each method. I set the links online because I think it's quite convenient for them. They don't know anything about it, and in a very short course they get a lot of information, so there they can check it more at ease. Because I did have the Reynolds book also, but I don't like that one very much, especially not for ours, because that's really more like, we're more agricultural scientists, so it's a different, Reynolds is really for geologists, I have the impression, or even geophysics, I don't know, it's another scale. So I liked actually more what you've been making online there. And anyway, so what I would like to work on here is, until now I've been using ERT mainly at small scale, so in lysimeters and in the field, but let's say I try to resolve at decimeter resolution, so often I have electrode distances of 20, 30 centimeters. And in 3D and 2D, and up till now I've been using mainly BERT and Gimli, which has now become PyGimli. But the thing there is that right now I think it's becoming available, but to use it together with other electromagnetic methods was not that convenient up till now. For example, with EMI. And so, yeah, that was the reason why I wanted to come and see SimPEG and to work with you on recent data we have where we combine ERT and EMI in the field to measure root order uptake of potatoes. So yeah, I hope I can learn how to work with the code for ERT and for EMI, and then maybe also to do something on combining the two and the petrophysics of the two methods.
Thanks, Sarah. That sounds great. Vahid?
Yeah. Nice to meet you. I'm Vahid. I'm from Institute of Geophysics, Tehran University. Actually a professor over there, and mainly I was active in gravity and magnetic as a lecturer and researcher for about 20 years. I did many projects in exploration geophysics, especially gravity and magnetic, and so I have a good experience in this field. I used several softwares during these years and in my publication and my interpretations. For example, Camacho's method, Model Vision, and the GeoSci, GeoSoft. But it's my first time that I'm becoming familiar with this Graph 3D and Mag 3D. This is the main reason that I came here. Also, Professor Oldenburg is a very famous guy in this field, and it's a good opportunity for me to be here for my sabbatical period. It's about 9 months or maximum 1 year. And I'm very happy to see you and meet you here. I just arrived about 3 weeks ago, and now I'm settling much better. It's difficult to find somewhere to live at first when you arrive, but hopefully everything is now becoming better. And I have my own data. It's about gravity and magnetic data set over the geothermal resources in sensor of Iran. I brought them here, I processed them, and I would like to model it by GIF facilities over here. Thank you.
Thanks, Vahid. Kevin?
Okay. Yeah, I'm in there. Hi, Sarah. Also looking forward to meeting you. Yeah, like coincidentally, like Vahid, I'm also looking for housing at the moment. It seems everybody has this problem in the city, but
it's the wrong meeting for this. It's a different meeting.
housing affordability and gentrification.
Yeah, exactly.
Tomorrow. Okay. Let's postpone it. Yeah, so I did my geophysics degree here at UBC, and then right after that, I went to Myanmar to do a 6-month volunteer placement. I think many of you have heard this story, but for those who haven't. And I was with, basically I was volunteering with the state level department in southeastern Myanmar in a state called Mon State. And I was working inside of there basically to train the engineers in geophysics. Actually, something I discovered a bit late in the process was that this government department did not actually have any geophysical equipment themselves. So, this is a really big problem. How can I teach them if I don't have any equipment? So with a friend of mine, we found this design by a professor in the States for a relatively shallow vertical electrical sounding device to do 1D surveys. And we built that device with some funding from the state government in Myanmar. At the time, the maximum penetration depth was only about 30 or 35 meters. So for relatively shallow investigations. And basically we were trying to train them in how to site wells and find the best places to drill. Because over in that part of the country, there's dry season lasting for about 2 months. And basically tens of thousands of people, they have very few options when it comes to water. They rely on government donations, but if the government doesn't come, then there's no water. And it's really tragic. Mm-hmm. So I went there to try to, I guess, help build capacity with the government. And I'd say we got a decent start. basically we were able to test and calibrate the instrument, and we also made an upgrade. So now it can go to about maybe 90-meter depths. And I wish I had more time. Towards the end, I think if I had a few more months, then we'd be able to go use this improved device and do better surveys. But I ran out of time. So I think with GIF and with everyone here, I'm also really interested in open source materials. We're trying to get funding with an organization called Geoscientists Without Borders. They're part of the SED, actually. Trying to get funding to do a sort of follow-up project to do those things I wish I could have achieved the first time. And teach them more effectively. And so I'm really hoping to take advantage of the GPG and GeoSci and all those things, and maybe help improve some of the Jupyter notebooks that they also use in the 350 course. And just so we can go there and then do a training for a few weeks and really get them up to speed. Hopefully we'll also be able to procure an ERT device as well, which I didn't have the first time, if we can get the funding for the project. Yeah, and generally I'm very open to learn. All of this is new for me, so I'm really excited. Yeah.
Okay, so we've heard from the guests and from the established hands. You want to take it away, Thibault?
All the way. So hi, I'm Thibault Asik. So that's my 4th year as a PhD student at the GIF. My focus are mostly on integrating geological and physical constraint in the inversion to really try to constrain, better the recovered result and force the recovery of certain key features that we want to see. So, and try to do that not set it predetermined, but let the algorithm learn what's where and with which values. So we're working right now on the first foundation article with Doug. Hopefully by the end of the week or something like that. We'll see.
Okay.
Mike?
I'm Michael Mitchell. I've been here for about 7 years now, trying to finish up my PhD with Doug. Mostly looking at the use of DC resistivity and electromagnetic methods inside of mine workings or tunnels to try to just kind of image the rock around the tunnel. So I guess the initial part of the work was related to kind of data quality control and how to kind of go through these big 3D data sets and kind of try to winnow out the data that are really badly noise contaminated from those that are kind of usable. And then the portion that I'm trying to finish up right now focuses more on the survey design side of things, just kind of where to place the electrodes kind of along this tunnel so that you can kind of make the most out of kind of the limited geometry that you have when you're in the underground setting.
Okay.
Hey, John?
So just a question, do you also do inversion of EM data then, or?
I mean, I haven't really, so the EM, the extension of it, right now, most of the stuff I've been doing is on the DC resistivity side of things. And then I'm just going to try to take some of those ideas that we've developed for the DC resistivity and kind of extend them into the electromagnetic regime and kind of show that we can get a lot more information from the electromagnetic data.
Okay. Because that's one of my questions too. I don't know whether there are some specialists here around the table, but I am working on this project with Jan van der Kruk from Jülich. You probably know him, huh? And they have their own MATLAB-based inversion code for EM data. But I was wondering in how far with SimPEG we could do 1D or other inversion of EM data or not.
I'm sure Lindsay and Sagi can probably speak to that better than I can, but I know that we have the capabilities to do that in SimPEG.
Yeah, we have 1D inversions hooked up and scaling to reasonably large data sets. 3D is hooked up, But at the moment, if you've got a big survey, it's not going to scale to that. But if you've got a fairly small survey, you can certainly forward simulate and invert in 3D.
Yeah. And so, because they always told me you need something like 6 coil data or something like that, is that, yeah, well, something we can talk about later, probably, the details, but yeah.
Yeah, we can certainly get into the details later. And maybe at the end of this too, we can try and compile a list of resources. I think with this group here, that would be like a great thing to figure out is what do people need and what are you looking for? Like what kind of questions you have and what kind of things should we be pointing to as you get started.
Okay. Well, one thing I already told Doug, I really want to help out on that because I think we'll probably be asking a lot of questions to you guys, and maybe what I can give back during my stay is also to really write down everything that for me as a dummy is important to know to be able to work with the code. Maybe you can make some kind of guide for dummies then with all these things.
That would be extremely valuable.
Well, I think that's going to be kind of a self-evolving aspect here because Sarah and Kevin and Vahid are all sitting in exactly the same office space and we all have a lot of the same goals in mind. So if they can mutually agree on what the path forward is, then everybody will be completely on board.
Fill the holes.
Yeah, all the holes are filled. Dom?
Okay, I'm Dom. I did my undergrad here at UBC. I did my master's with Doug, and now I'm a third year, I guess fourth year PhD. So I did my entire academic career at UBC. Mostly focusing on potential fields like MagGrav. I did also help with the SimPEG DCR. So we'll be able to collaborate a little bit, Sarah, on that side. Okay. My focus is really on try to do large-scale inversions with potential fields. So parallelizing and yeah, just try to do bigger problems because that's what we can do with potential fields. We can afford to do it.
Okay. So right now the code SimPEG is not parallelized, or?
Yeah, we're working on it. Not all of it is parallelized, but it's on as needed basis. But I think DC, Sagi and I are thinking about it, and that's going to be the next item.
That's great. That's really good because I remember when with normal transect data I don't have that problem, but when I had my lysimeter data, it was a big problem actually that BERT at the time was not parallelized. It used to take like I know a day to invert all my lysimeter stuff, and then for just one time frame. So actually used 10 nodes at the same time on the cluster to be able to do a long time-lapse inversion.
Yeah, like a huge speed up for us was last year. Joe at the Colorado School of Mine rewrote the octree meshes, and that really was a game changer for us. So DC octree will probably gonna help you a lot too. And yeah, looking forward to push it with you.
Yeah.
Oh, Sagi, I see you've joined us. Sagi? Hello? Sagi?
Hi, can you hear me?
Yeah. We can hear you.
Perfect. Yeah, here we don't really have a good sort of meeting space. Sometimes I need to move around. Like I was actually kicked out. Anyway, I used to be in UBC. I did my PhD with Doug. I used to work on induced polarization problem, and also connected to electromagnetics. And now I'm in Stanford now, working on like a water problem using airborne EM. Yeah, so that's my background.
Okay, great.
Yeah, nice to meet you guys.
And Lindsay.
Hi.
Hello. Like Sagi, we actually started at the same time and finished up around the same time. So I did my PhD at UBC, mostly focused on electromagnetics. I've done a lot of work looking at steel case wells, and have done a lot of development in SimPEG all throughout, as well as with like the GeoSci resources and sort of open educational content. Now I am at UC Berkeley, and I'm working with the Jupyter team. And so a lot of my role here right now is figuring out how do we make Jupyter more useful for geoscience workflows. And so we've been working on exciting proposals, sort of connected with the PanGeo group. I'm not sure if you are aware of them. If not, that's something to have a look at after this. So.
Okay.
Yeah, it's very nice to meet you all.
That's great. Yeah, I'm not really sure what the best trajectory is here. Lindsay, do you have an itinerary or a few things you wanted to talk about?
There are a few items on the list. So there's Dom's added a point on progress updating on Dask for the combo objective functions. So for those of you who don't know what Dask is a great way to parallelize codes in Python. Dom, do you want to maybe give us like a high level, and then we can sort of go into the details perhaps next week? Does that sound appropriate?
Yeah, that sounds absolutely appropriate.
Okay.
Okay, so for those the new person, we try to modularize everything in SimPEG, right? So like if you think of the math, we have like the regularization, and then we have the forward problem and all this, and all these are blocks, right? They're building blocks, and then they form an inversion, something like more complicated. And so now we're trying to parallelize, like we parallelize the forward problem, and now we're trying to parallelize the inversion level, which is kind of like the upper level, Yeah. And so I'm experimenting with Dask, which is a library in Python that just sends jobs to different CPUs, do the processing, and then collect it all back and give it back to you, right? So I'm just experimenting with ways to parallelize it the most efficiently.
Dask.
Dask, yeah, D-A-S-K.
So is that something like OpenMPI or what?
It does both, yeah. So you could do OpenMP style where you send it to many workers, or you can do like an MPI. Sorry, MPI where you send to many workers, or OpenMP multi-threaded. So it does both. Yeah.
Okay.
That's the beauty of it, is that we don't need multiple libraries. We could do it all just with Dask.
Okay.
And it performs on cloud as well, which is really cool.
Ah,
So
yeah, okay.
like we can sort of write to parallelize with Dask, and you can deploy it on whatever you want.
Mm-hmm.
And are you having any challenges with that, or like, or so far?
So I think the only issue that we have right now is that, well, I kind of figured it out, but the sparse matrix operation with Dask is a little bit complicated.
Yeah.
It needs to be treated like carefully, because every time you end up with a sparse matrix operation, it bottlenecks there. So we need to be a little bit careful. But yeah, run some tests. You guys can see my screen here. Just very briefly. So usually in SimPEG we have like forward classes like this, right? So we have this is a Python class that does something. You don't have to worry about it here. I'm just creating a random matrix, right? A 10,000 by 10,000 random matrix. And then the forward problem is just a matrix vector product. So the A matrix time a model, and then that gives us data, right? It's just something simple.
Okay.
So in the current framework of SimPEG, if you have multiple problems, let's say you have multiple transmitters. Currently, we're just doing a simple loop over all the transmitters and doing this dot product in series, right? So maybe this part is parallelized, but the loop over all the sources is not. It's just a straight up for loop. And so now we're thinking, let's just parallelize this for loop, because yeah, if we could do all the forward models at the same time, if we have multiple processors, then we just throw more processors at the problem. And this is what Dask does. Dask with the decorator, you can just ask that function to wait, and then Dask just builds up all the functions that you want to do. And then when you ask to compute, it creates a graph and then send it to all the processors. And this is the runtime in series versus the runtime in full parallel for the forward problem. So we'll be able to have a huge speed up. And obviously, the more sources you have, the better it is, right? This is, I think I had here.
So that was 32 seconds versus 0.2 seconds.
That's right. That's right. And then with Dask, you can show your processes. So I'm just gonna show that to you. All right. So that's just a way to display the processes that are happening. So it's the same problem in a Jupyter notebook. And I'm just going to show you how the computers are interacting with it. So this is the problem in series, okay? And so every time you launch a process, it recreates a new graph, and then it sends the job on the processors one after the other. All right, and that's what the part that takes time. I'll let it finish. So what you're seeing here is just sending jobs to all my cores one after the other. Okay, so it's gonna finish at some point.
So this is something you'll have to teach me how to use this Jupyter and so on to do it in a correct way, because I've been using MATLAB mainly up till now. I know a bit of coding in Python, and I looked at Jupyter. It's really great, but I don't have a correct workflow at the moment for that.
Yeah. Okay, so you saw that, and then now if we do the whole thing in parallel instead, like the full parallelization, you'll see the graph is going to be super wide, and that's what you want. You want a very wide graph, and then you want all the processors to be busy all the time, right? So the red is what is being processed, and green what is waiting, and then now all my processors are just working full time all the time, 100%. So there's no downtime between each forward model. That's kind of the idea that I'm working on right now. Yeah.
That's really great. Yeah.
Nice, Dom. That's really exciting. We can maybe follow up offline at some point. I'd like to get from you some ideas on like the simulation costs, and based on like what you've learned through these examples, and what we should be thinking about at that stage.
But they don't want to be called USGS.
So Dom, did you kind of figure out like a kind of two-level parallelization problem? Like, let's say you got a simulation level, like you use 10 processor or something like that, but you got an inversion level, let's say like, I don't know. So let's say you got total 100 processor, and like kind of, did you figure it out in like a higher level, and then you have also another level that can, you know what I mean, like a two-level problem parallelization?
Yeah, so the highest level SUG is on when you calculate fields or the derivatives, right, on the combo objective function. So currently we're looping over.
Right.
If we put a decorator at that level, it will detect if there is any Dask parallelization downstream. If it doesn't, then it will just consider them as a series. But if it sees any Dask, then it will add them to the graph, and then it will optimize it downstream. It's really easy. That's the beauty. It's really easy.
Okay.
Dask figures all that out for you, as long as you're using Dask all the way through. I think if you start mixing multiprocessing and Dask, and you specify the number of processors on multiprocessing, I think that gets messy. But if you use Dask the whole way through, Dask just figures out the graph for you, and then you don't have to worry about it.
Yeah, no mixing. You can leave it unparallelized, that's fine, but if you're going to parallelize all the way with Dask, as Lindsay said, yeah.
Okay, cool.
Cool. Okay, so the other item that I wanted to make sure we have a chance to talk about today, because I think this impacts hopefully everyone in the room in a good way. We've done a lot of work assembling. Yeah, I'm just going to get people, if they don't mind, I'm not speaking, just mute your mic so we don't get lots of background noise. So with the GeoSci.xyz site, we have the GPG, and we've got electromagnetics. And we've assembled a whole bunch of resources on inversion. We've created a bunch, but they're sort of scattered all over the place at the moment. And so this has been on the radar for a while. Is to create a site called inversion.geosci.xyz. and this very much could supplement a lot of the SimPEG documentation. So the SimPEG documentation would sort of assume that you already understand all the details of inversion and just walk you through like how to piece an inversion together. But inversion.geosci.xyz should provide like an overview of various components and various decisions that you're making along the way. So like how to design a mesh, what different regularizations do, looking at things like the beta cooling schedule. So stuff like what we've done in the MT tutorial, what Phil's done in all the directed studies stuff that he did. So right now, I think the biggest thing that we can do is, first of all, assemble everything that's out there that we've done. So I started with a brain dump of what things are that I can remember that we've done. So if anybody has any other ideas, please add those links there. Then I think the next step is to actually then create a bit of an outline for what this website should look like. What are some of the topics that we need to talk about? And this is where it would be great to get input from everyone, is like, what are the questions that you're trying to answer? And how, like, what are the things perhaps that SimPEG you're interested in learning about and you would be interested in helping write a tutorial on? Because then we can find a place as to where that would fit, point you to the right resources, and then have that be something that's captured and then can help people in the future get onboarded with SimPEG and understand what's going on there. Yeah, so Doug, are there things with that that you would like to mention as well?
Not specifically. I think the main thing here is for us to, yeah, just get a place that we can start to put all of the material that we want to have for inversion, and then to gradually build up a sequence of notebooks that allow the user to kind of get through all of the really important parts of this. So whether it's from discretizing, well, just all of the elements that that Lindsay has said, and we do have a lot of things that we've kind of done little bits and pieces here and there. So I think this is an opportunity now to really take a step back and then put something together that's useful not only for the current people here now, but if we satisfy everybody who's sitting around the table here that, oh, this is really all I need. I could just go to this website and I'd have basically a self-directed routine here for how to get through, how to understand inversion, how to implement it in SimPEG. It'd be great, and that would be a big check mark, and then other people could undoubtedly handle it. So that's really the goal, and I think especially over the next month to really try to see how far we could go with that with respect to developing some notebooks and really making it everything understandable and useful. So just start by accumulating things, and then dig out a few paper tutorials about what inversion is, and look at some of the stuff, and just see if we can't just put it all into practice, so it's just really understandable and we know exactly where we are.
Yeah, thanks, Doug. And sorry, was somebody else going to jump in and say something?
Yeah, sorry, Lindsay. I just wanted to clarify. So the intention is to develop a resource, which sort of like for people such as myself who don't really know anything about the details of inversion, like just starting really from the ground up.
Absolutely. Yeah.
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 Okay.
Yeah. So like
we see this actually as then being part of a larger course that we could take, or material for a course that. So we envision at some point maybe going and spending a week someplace doing inversion. In the immediate future, we're going to go to Argentina and give a short course there, basically just 8 or 10 hours, just to kind of go through things. But have a resource that people could really understand what inversion is and how it's applied. Because it's quite interesting when Lindsay and Sagi and I went around the world in this short course that we had for electromagnetics. There were so many people out there who had access to 3D inversion codes, and especially magnetotelluric codes, but other types too. And they're putting up stuff, and they're putting up results, and you're looking at those results and you say, there is no way the Earth could ever look like that, right? And so you start to talk to them about, okay, what they've got. They say, oh, well, we've got this 3D inversion code, right? And then they start offering the right words, like, oh, they start, here's my regularization function, here's my misfit, here's my Tikhonov curve, right? So they got all the words. And then you ask them something that's just a little bit lower down, and it's like it's not there. So at the end of the day, they end up basically bringing stuff in, pushing some buttons until they got a picture at the outset, and have no way of critically thinking, yeah, that is a possible good answer or not. And so it's in really trying to emphasize those fundamentals, emphasize how the critical thinking for inversion works, the importance of the regularization function where all your prior information is going in, and just all of that due diligence is so critical to getting a good result. So those are the things that I think we really want to emphasize, and those are at the absolute basic level.
Yeah, and so like in terms of technical level, sorry, Sarah, were you about to jump in?
No, sorry, no.
Okay, so like the resources that we put together, like the GPG and EM, we sort of don't really talk much about code and don't really get into that. This would be different. So this we will like show people code about how to use a mesh, like how to build a mesh, what things are, how like finite volume works, all of that sort of stuff. So I see this like very much as like a next level. Now people are interested in actually using a bit of the code, but we're going to teach the code and the theory together. So I think like Phil's notebooks that I put a link there. Yeah, one of the first ones is a nice example of like how we might think about weaving these things together. Yeah, so like if people, especially the new folks who have joined the group, if you'd be willing to just like flip through these resources, and then also I started in the notes there just a section on questions, and like if you just have general questions about inversion or general questions about using SimPEG, more on methods at this point, less sort of technical, like how do I, run a joint inversion with SimPEG, much more on like, okay, what does, if we choose an L1 norm versus an L2 norm, what does that do in the inversion? Those kinds of questions. If you'd be willing to just like brainstorm and throw some in there, that would be really helpful, and we can sort of take that and start to flesh out a bit of an outline. Mm-hmm. And then basically hopefully figure out, point people to take on given topics within that outline. And so we can pair up people who are interested in working on common topics, kind of like what we did for EM GeoSci for everyone who was involved in that. Yeah, so how does that sound?
That sounds good, yeah. That's no problem. Just that, yeah, this kind of questions is probably, I'm already a bit biased because, yeah, I use them already for a few years, and it's mainly from the DC resistivity aspect that I'm thinking. But yeah, I can go through it and see what I have as questions still left and what I think of my students always ask me and things like that.
Yeah, absolutely. I mean, so this is also hopefully a resource that's useful for you. So if there's questions that keep coming up for you.
Yeah. I think the thing with the norms is quite important, and especially, I don't know whether you have this also in SimPEG, but for example, making the difference, we have a lot of things with time-lapse, and so to explain that you can have different regularizations in different dimensions and stuff like that is also interesting, and which would go where, or which would be most useful for which dimension would also be interesting, for example.
Yeah, absolutely. So like any of those kinds of questions, and totally feel free to take whatever bias you have and channel it here, because this is meant.
Okay, and so where should I go to put these comments and questions?
In the Google Doc.
In this Google Doc stuff, okay.
Yeah, we can just keep it in here for now, and then we can parse it into something in the coming weeks.
If I may, I want to say that you're really very well organized. I'm going to take this kind of approach for my conference calls as well for the future.
Sure. Yeah, well, it gets harder when everyone's in different places, so you have to have.
Oh, it's great, yeah.
Groundwork. Yeah.
And Sarah, we're you're speaking to a good crowd here, and when you talk about biases, we're completely 100% with you, but we also cannot forget variance. So, you know, just saying.
Okay.
Excellent. Well, I need to run here shortly to another meeting. Are there any final comments, questions, thoughts?
That's great. Thank you.
I just want to say, Lindsay, I've been looking for some kind of inversion info dump. So this is fabulous. Definitely, I'm going to look through these. This thing that I have. So thanks.
Cool. All right.
Okay.
Well, thanks, everyone. Nice to meet you all.
Yeah, nice to meet you, and see you next week then. Is this meeting every week on Tuesday?
Yes, every week.
Yeah.
Yes.
Great. Then we'll see.
But you'll be here in person next week, Sarah.
Sorry?
I say you'll be here in person next week.
Yeah, I'll be here in person. So, see you. Bye-bye.
Okay. Bye, guys.
See you.